Take care of this. What is this?
No, this is for Lisp because I was there and there was no one. I don't know where are the hours.
I don't know. Do we have to pick them up somewhere?
Yeah. No, they should bring it to us, no? That's how it works.
I don't know. I don't know, but we are on time, so should start. Okay, you can go one by one. Is that
Something ugly can come out from all this. You know that I should have tried the laptop before because mine always been problem.
So hi everyone, this is the INTAREA working group. We're about to start. Okay, it's coming. Yeah. That's your other screen.
That's all. You see, the screen is always displaced. That's the problem.
But if you move it just a little bit to the left, like when you passed, yeah, that's good. That's good. And then you don't see.
It here.
So hi everyone. We're just doing some final adjustments to the slides here, and we're going to start. This is the INTAREA working group agenda. Well, the INTAREA working group slides. Yes, perfect. Thank you very much. So we have a JavaScript. Does anybody want to help us with taking notes? Ian, anyone else? Thanks, that's appreciated. So we're just having some little issues here with the slides. Okay. Okay, that's good. Okay. So everyone, this is not well, as usual. Please make sure that you comply to the IETF rules and BCPs. This is an official IETF working group. Yeah. Ooh, yeah. And well, we get some help here. We have to comply to the IETF guidelines for IPR declarations, as this is a normal group. So please make sure that you're aware all communications are officially recorded, and this is an official group. So while Stuart gives us some help here with the tech support. Excellent. We have a pretty full agenda. We got a few late requests that we have accommodated at the end, time permitting. So we want to request presenters to try to do their best to be brief with their presentation so that we can go through as many as possible presentations. Okay. So we have a minute taker. We have a JavaScript. Again, remember your presence is logged. Blue sheets. So, okay, we don't have blue sheets yet. We will take care of that, but when they pass around, please make sure that you record your attendance. Again, we have a pretty full agenda. This is it. It's posted, and it's actually 2 pages, so if you go to the next, please. These are the presentations that we will accommodate if time permits. So, starting with a working group update. With the documents that we have progressing, we start with the tunnels. We have received some slides from Joe that have been uploaded. Unfortunately, neither Joe nor Mark are present, so they are requesting to have the discussion on the list as compared to having the discussion here. And just for as a reminder, the document status is currently informational, and the question is, should this still be an informational document or become a BCP? For that, we have to take into account the impact on other RFCs, and there's some examples there. And they are asking for feedback and recommendations for other RFCs and Section 5.5. So we want to keep this brief. This is just a reminder, and as the authors are requesting, we would like to have any discussion about this on the mailing list. Is there any question for clarification on this? Okay, here none. Next. So more documents that we're progressing. We'll have the INTAREA hosting practice, which was adopted in Prague, and the chairs will request publication after this meeting. So that is on the go. We have the INTAREA ad hoc wireless, for which Charlie hopefully will present an update. Next. Then we have a couple of calls for adoption on the INTAREA IP and UDP. That generated quite a long thread of discussion on the mailing list, but we couldn't see any working group support for adoption. We also looked at draft IETF NV03 GUI, which got adopted by the working group, and Tom will soon present an update to this version 03, now with 04, as well as a companion document. Okay. Other documents, there's the multicast over IEEE 2 wireless from Charlie and et al. So the authors are going to work on a new draft because there's an IEEE 2 meeting next week in San Diego. So we'll be working on that, and hopefully a new revision will come out. And then we have a couple of announcements. There's an IAB announcement, and Carlos will do another announcement next. Okay, so agenda bashing, are there any questions or suggestions on the agenda? If not, we'll let Brian do his presentation.
Just a second.
It's yeah. There.
While we're waiting for this to come up, hi, I'm Brian Trammell. I'm the, among other things, I am the IAB lead for the IAB Stack Evolution program. And the reason I'm here is this came up in the, so there was a kickoff meeting at the beginning of the week. The IAB and the ISG got together, and it's like, okay, well, you know, we have these programs, and a lot of people in the affected areas may or may not know what they do. So, well, we could just talk to each other and fix that. So who here has actually heard of the IAB Stack Evolution program? Okay, I'm even seeing a couple of people whose hands are up who I don't know personally, so that's good. View, enter full screen, all the way at the bottom.
I just can't see completely.
All the, keep going down, 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 down. Yay, but not slideshow, because then it's a Fechakucha. So basically, this is a, you know, this is an attempt to take an immovable object and hit it with an unstoppable force. It's hard to evolve the stack, but the stack evolves anyway. Is there any way that the IEB can help? And are there gaps in work in the IETF where there could be sort of engineering fixes to some of these problems? So in the say that the stack is hard to evolve. I mean, there's these many layers, and some people in this room may have heard of the IPv4 to IPv6 transition. I'm assuming everyone here is okay. There's probably some slides you can find on that if you haven't. And so some of this was driven forward, and some of this is actually sort of like, various actors who have responsibility for different parts of the stack, sort of moving it in different directions than we originally thought. So this is what the IEB Stack Evolution Program looks like. Can we help? Since the program was sort of rebooted in 2014, we've done 2 workshops, 2.5 workshops, Semi, Marnu, and IOTC. So we're kind of looking at IoT things and how IoT things have to do with various layers of the stack, because there's no program to look at the whole IoT thing. And then 3 BOF, Spud, Accord Plus this morning. That was a great deal of fun. And then there was a BARBOF on measurement that led to the measurement and analysis for protocols research group, which was a proposed research group, but since I made these slides, it's now a real, actual, full-blown research group. So there's not a whole lot that we've done that really touches on INTAREA so far. There may be, as we look at how sort of things in transport interact with things down at layer 2, because there's this layer 3, and that obviously has some interactions there. Watch this space. There's 3 ways to participate. Basically, we have an open list, stackevo.discuss@ieb.org. That's actually been relatively quiet recently because most of the people who are paying attention to that have been paying attention to the BOFs. So there was the Accord BOF last time, the Plus BOF this time. When there are BOFs, show up at them, and then the IEB will announce on the IETF list if there are announcements for workshops. When a workshop is announced, usually that's invitation only, send a position paper. We have sort of smaller room conversations. Anything that we think is a big room conversation, we try to get the IESG to approve as a BOF. So with that, if you have any questions, feel free to ask me, that or via email, or send a message to stackevo.discuss@ieb.org. Thank you very much.
Thank you. Any questions for Brian? Okay, thanks. Hearing none. Carlos? We're going to get an update about the Internet Area Directory. Please go to the mic.
Okay, well, the slides are being brought up. I'm Carlos Bernardo from UC3, and you may
Could you speak closer to the mic, please?
Okay. I'm Carlos Bernardo, so you may wonder why I'm here. Well, I'm one of the Internet Area Directory coordinators, and I'm just going to report on an update that we have been discussing together with the ADs. Well, while we get the slides, basically what has been doing the Internet Area Directory so far. You may be aware of the Internet Area Directory. You may be even a member of that. And what we have been doing so far has been reviewing documents upon request from the ADs. So that's basically what the Internet Area Directory has been doing. In the slide, you will see that there is a list of the people that kindly has been part of the directory and has provided quite a lot of nice reviews during this time. And we thought that and the ADs wanted to have, so next slide. So that's so that's basically a huge thanks to the people that is in the directory and has been doing reviews so far. So next one is about what we want to, or the ADs want to do with the directory in the future. So this is basically a summary of what we are going to do. We are going to review all Internet Area documents prior to the IETF last call. So that's going to be mandatory for all the documents. And the outcome of that will be a recommendation from the reviewers. We will have at least 2 reviewers from the directory, whether the document is ready for going to last call or not. So that's the first thing that the directory will be doing. The second thing that we will be doing is to review all documents that are on IETF last call and identify those that tackle somehow impact or has some relationship with the Internet Area. And if that is the case, to also provide a review. And to provide a review to the ADs, basically suggesting the valid position. So should this go forward? Should this be discussed? And also, of course, provide feedback to the document share and the authors. That also applies to the first case, to the Internet Area documents. Well, there may be other things, that reviewing documents upon request from the AVs, as we were doing, and helping other things. But the main two topics are the review of the Internet Area documents and review of all documents in IETF last call that may have an impact on Internet Area. Next one, please. So how is the directory formed? So, well, it's basically the members are selected by the AVs. So if you are interested in being part of the directory, please do talk to the AVs, and that will be very, very helpful. And now one very new thing, maybe that's something that will be new for all the chairs of the Internet Area, is that all the Internet Area working group chairs will be part of the directory. So that's something that present. Don't blame me. So that's important because we'll have a lot of more presence there, and also with more background. And I don't know if you want to comment on this? Or?
No, go ahead.
Okay. Well, two of the members of the directory act as coordinators. For the time being is Bernie Bowles and myself. And then just quick thing on the member responsibility. You are part of the directory. You have to respond upon request very fast. So I can do the review, or I cannot do the review right now, and then provide the review within 2 weeks by default, or by the deadline that is set on the request. And the last slide. All this information, together with much more detailed things, will be up in the Internet Area Directory webpage that is being updated. So the information that is there right now is not yet updated, but it will be done in the next few days.
Okay, thanks, Carlos. So Suresh Krishnan, AD. So the thing is, like, we're trying to harmonize like this directorate with like a lot of the other things that are happening. If you look at SecDir, this is kind of how it works. So the chairs all get into the pool by default, and they try to review like all the documents going through. And we haven't been doing that in the past, but it kind of starts to make sense to do this as a way of like one thing that's not written down here, but it's something that's like on our minds as AD is like succession planning, right? Like, so there's one thing we want to figure out is like we want to have a team of talented people who are like able to go through documents from other areas, trying to find touch points and everything. That makes our life easier when we have to replace ourselves. Okay, so that's one thing that's kind of not stated here, but it's something in our thinking. Second thing is we want to do systematically review all the documents, and that cannot be done without a larger pool. So there's like a nice set of people that are in there, but it's not sufficient with a number of documents going to IETF last call. So it's kind of we are opting in all the Internet Area Working Group chairs, but you are free to opt out. If you don't want to do it, like we won't like it. But if you want to opt out and not do the reviews, like yeah, just come and talk to the ADs or the coordinators, and we can opt you out.
Juan Carlos Zúñiga, as an individual. So are you expecting a certain number of reviewers every time, like from the directorate, or do you have any idea of what's?
So there's going to be like a round robin list. That's how the other directorates work. So there's like all the list of reviewers in there. So whenever a document comes out, the first person on the list does it, and it's probably like going to be one review a month, I would guess. Like if we get the right set of people.
Okay, thanks. All right. Any other questions, Carlos? Okay, thank you. So next is Tom. Sorry about the technical problems. It's coming up. If you want to start an intro.
Okay, so we'll deal with the blue screen in a minute. My name is Tom Herbert. Today I'm going to talk about generic UDP encapsulation. I think I presented in area before. Why we're here today, we're planning on, or I guess, is it a working group item officially?
Yeah. So we did adopt the document, the previous revision. you did a new revision, and then there's a companion document, right?
Okay, so we need to get the,
So the
label change on the title.
Exactly. What was the difference between 3 and 4, and then what's the companion document talk about? I guess that's
Okay,
what.
great.
We,
So I'll be representing Lucy Young and Osama Zia, the co-authors. Just a brief background on GU. It is a type of encapsulation within UDP. We are explicitly designing it to be generic and extensible, and it will have virtualization and non-virtualization use cases. Originally, this was an NVO3, but we decided to move it to INTAREA because very general protocols. So it seems more appropriate there.
okay, next.
GU is very much like GRE. In fact, it's essentially based on GRE, so we use a concept of flag fields. And in one sense, we can think of GU as being a successor to GRE. So we did find with GRE, it was kind of limiting extensibility. So GU was defined based on that principle to go beyond GRE and allow extensibility, but with the same model. Quick overview of the features. So as I mentioned, GU is very much like GRE with flag fields. We added a header length, so this does allow for variable length headers and also allows middle boxes to parse over headers they don't understand. We have an IP protocol number, so one significant difference between GRE and GU. GU carries an IP protocol number, so that's the 8-bit normal protocol number. We use UDP encapsulation, similar to how we're doing GRE over UDP to facilitate CCMP. We have a concept of control messages versus data messages. One important extension is security. We have an optional security field that allows authentication of the header itself. And similarly, we have a checksum, fragmentation, several basic extensions that I'll cover in a moment. We targeted hardware friendliness, and as I mentioned, it does support network virtualization. Also, the fact that we used IP protocol number is not an aberration. We do intend on using this for layer 2, layer 3, and layer 4 encapsulation. There's a separate project we're working on for the layer 4 component. So this is the current format of GU version 0. It's actually simplified since the last version that we had done, taking feedback from Adrian Farrell. So it's a UDP header followed by a 4-byte GU header followed by fields and a private data section. So the flags indicate which fields are present, just like GRE. The private data is actually a section that is somewhat undefined in the sense that it can be used for private data. So an implementation or site could put in their own information. They could put in TLVs or flag information or the like.
Next.
GU version 1 is actually what I would consider kind of a special case. And this really came up with the IP and UDP discussions. And we realized that because of the format that we had in GU, we could actually directly encode an IP packet within the GU header and call it version 1. And this has the exact same semantics as IPv4 and IPv6 over UDP. However, since it's compatible with the GU version number, this is also a GU packet, which essentially means we can use the same port number for both direct IP and normal GU packets with a GU header. So the changes in version 4, which was the most recent change, as I pointed out, we simplified it. So we moved the concept of an extension fields bit, magic number. The interflow identifier is renamed flow entropy. That's basically the UDP source port used for ECMP purposes. We did describe the set of IP protocol numbers that are, in a sense, legal. Very few are actually excluded. The hop-by-hop options in IPv6, for instance, and IPv6 extension headers are discounted in IPv4. But for the most part, it doesn't seem like there's a reason to exclude any of the normal IP protocols at this point. We allow user-defined control types. We greatly expanded the IANA considerations. So there are several values that we need to define IANA numbers for. The checksum and some other things were deferred to the extensions draft, which I'll talk about in a moment. And we expanded on the security section, and also there's a what we're calling advanced security in the extensions draft. So that was the main draft, and then we have a companion draft, which is myself, Lucy, and Fred Templin contributed greatly to the fragmentation part of it. So this is consolidating what we kind of consider the fundamental set of GU extensions. So when we developed GU, we also had the idea that we would need extensions. So we kind of derived a basic set of what appear to be the fundamental core extensions that we'd want to have in an encapsulation protocol.
Okay.
And they are checksum option, fragmentation option, security and payload transforms, and remote checksum offload. Checksum option, it's very similar to UDP Lite, except we always cover the GU header, which is very specific with the header length, and we allow some portion of the GU payload to be covered. The reason we have a checksum in the GU header is this kind of resolves some tricky issues with the IPv6 checksum in particular, and this will include a pseudo header. So the idea is that we can use the GU checksum to include the pseudo header, and that allows us to not use the IPv6 checksum, which can be, it doesn't have to be used, except the restrictions on not using it are pretty complex, as we've seen in GR over UDP and MPLS over UDP. Next slide. Fragmentation. This basically is an idea from 4459. The idea is to put fragmentation in the encapsulation layer. Joe and Fred have obviously been talking about fragmentation on the list a lot. This is part of the discussion, the idea. It's pretty straightforward. It's much like normal IP fragmentation. We do get to put a fairly large identifier in, which is obviously helpful. And one of the things about fragmentation in the encapsulation, it's actually very efficient. We only have the outer IP header replicated. There's no inner IP header that's replicated. So it's IP header, GU header, and then basically the fragmented packet. Security option, as I mentioned, also is very important. This is a variable field to accommodate various security protocols. So right now it's defined as a 64-bit, 128-bit, or 256-bit field. It's opaque in the sense that in order for security to work, obviously the endpoints have to agree on the meaning of it. And we have a couple of examples of how this might be used. Simple security cookies, secure hash could use other algorithms to whatever extent we need security. Payload transformation option is kind of related. This is the idea that we will want to encrypt payloads often, maybe sometimes compress it. So the idea of the payload transform option, this tells what the payload actually is. So our first definition for this is DTLS. So this allows us to have GU DTLS payload, and the DTLS obviously protects the payload with fairly strong security. Next slide. Mm-hmm. Remote checksum offload is an optimization. This is for NICs, network interface cards, that compute the TCP or UDP checksum of packets, however, are not capable of looking inside an encapsulation to do the computation. So we actually found some tricks. If you turn on the UDP checksum, there are ways to derive the inner checksum if we know where it is. So the idea of the remote checksum offload is to emulate sort of a checksum offload, but the packet actually goes to the receiver, and the receiver can deduce what the correct checksum is on the basis that the outer UDP checksum was correct. So it's a really nice performance optimization, and we see pretty good results with this, so we kind of like it.
Okay.
So I guess the request we're making on the INTAREA is to adopt GU, so apparently that has happened. The GU extensions, if you haven't read the draft, I believe they're pretty straightforward at this point. Please read those, and we would also like to adopt those kind of as the companion document.
Okay, thanks. So that's a reminder. So we've already accepted to inherit from NVO3 the GUI, okay. And you heard what the differences are from C3 to 4, and there's the extensions document. So I guess the next step would be to request adoption of the extensions document on the mailing list. But okay. Does anybody have any questions for Tom or quick feedback? Okay.
David Black. Tom, not so much a question for you, but I think a general question. After Ross Callan's talk at the plenary, where and who should be writing the document on which encapsulation to use for what? Because we certainly have enough of them.
So you saw my question too at the plenary, right? So you gotta like the irony that I'm presenting another UDP encapsulation and I'm asking why we're doing so many UDP encapsulations. One way I would view this, so obviously MPLS in UDP, GRE in UDP are done. The difference with GU is it could theoretically subsumes both of those and any other IP. So in some sense, it's obviously an ambitious goal and obviously won't happen, but this should be the last encapsulation protocol we have to have for UDP.
Which, as you heard from the working group's response, I think that's been the story for the last 6. Okay, actually, it is a serious question because this is not going to be the last one. We certainly have enough, and some kind of guidance and architecture document about which ones you ought to use where for what purpose would probably benefit people who don't follow the encapsulation development work here in detail.
So yeah, Suresh Krishnan, so I don't share the optimism that this will be the last. And if you want to know why, Google XKCD standards, and you'll probably find like, something. But I do believe that like something like Dave did like is useful because we had like similar things with the V6 transition in SoftWire. So we had like SoftWire, Behave, like a bunch of things to do, V4 or V6, V6 or V4, V4 to V6, V6 to V4, and so on. And so I think it's like something that's important. And if you can identify like the kind of the differences between like how GU can be used versus like something else, like that would be useful for somebody to pick GU.
Okay, that's a good idea.
Thanks. Okay.
Thank you.
Thank you very much. So next in line is Rolf. He's going to speak to us about the update to the privacy considerations for IP broadcast, multicast.
Right. So I'm quickly going to recap on where we're coming from. So we did a couple of experiments, one here at the IETF in Yokohama, if you remember, and one on a fairly large campus network. And what we did, we recorded all broadcast and multicast traffic. And it turns out that there's a lot of personal identifiable information in those protocols, and a lot of these protocols don't come from the IETF. So the privacy problems we saw, for example, was host naming. So a lot of people name their host after themselves, which if that is broadcast, obviously everybody knows your name and potentially your identity. And that is basically covered in this document that you saw earlier at the CHESS presentation. So this is basically done. There's a lot of usage of persistent identifiers, and that has big implications on a couple of things that's being done in the IETF or IEEE, where you talk about IP address randomization or MAC address randomization. If you randomize your MAC address, but you have a persistent identifier that is broadcast to everybody on a LAN, why even bother, right? It completely destroys MAC address randomization. And a couple of protocols do this. We observe protocol behavior, and a lot of protocols frequently broadcast, and frequently means like 4 times a minute. And that's a lot. So you only have to be on the network for a couple of seconds, and you have seen everybody on the LAN. There's a lot of protocols out there that broadcast and multicast, so you can correlate data, and we did that with a bunch of protocols. And at our university, for example, we could reconstruct the social graph of students. So we didn't even know who they were, but who they shared data with, just by looking at broadcast and multicast data. That was actually quite interesting, and we had a lot of discussions with lawyers along the way. And we looked at a couple of the apps that are actually using broadcast and multicast, and very often it's not configurable when to use that feature of the application. Some of them you can switch it on and off, but you can't really configure it. And when I say configure, I mean something like if you're a Microsoft Windows user, for example, you can configure your wireless LAN based on SSID, saying you're at home, you're at work, or you're in a public space. and then Windows is behaving differently, so it's not responding to ping anymore and things like that. And we haven't seen that in those apps. So the problem very often is proprietary protocols, so non-IETF protocols. And because IETF protocols are fine, we believe, for 3 reasons. So there's people looking at these protocols that have something to say, in particular, like the security directorate. They're being reviewed. People design them carefully. A lot of people have something to say about them. And we have documents that deal with privacy. For example, this one here, DNSSD privacy. We have RFC 70 and 19, which deals with DHCP privacy, and a bunch of others. And there's operational support in product. So there's a lot of wireless access points, for example, where you can enable DHCP snooping, which means the access point will see that's a DHCP packet and not going to rebroadcast that packet on the wireless interface, because then you can have a rogue DHCP server or something like that. So there's products that actually deal with these protocols, and they can because they're openly specified by the IETF. So IETF protocols aren't the major culprit here, but it's proprietary protocols because they receive none of this. No review, no input, no operational support because they are largely unknown. So in this document, we have some protocol design guidance for these kind of folks, to avoid these privacy problems that we have observed in real operational networks when we did our experiments. For example, where you reveal the identity and social graph of a user, that's not what you want. And as I said before, we really want to avoid that these protocols break things that happen at the IETF or other SDOs, such as IP address or MAC address randomization, because it completely destroys all these efforts. So if you're an app developer and you have this cool broadcast feature, you can completely destroy IP address randomization. You should be aware of this, right? You should go somewhere and look it up and say, okay, I shouldn't do this because I'll destroy this. Right, and we want to help build better protocols, of course. So I think with this document, we're at a point where we either say we're going to adopt this and progress it towards an RFC or kill it. And that's your decision. Okay.
Okay, thanks.
Question?
So as a reminder, this is a document that we've been looking at for a while since experiment. There's been support and there's more details that have been added progressively. But yes, I think the idea would be to eventually adopt this document. So we really want to hear from the group what the opinion is. Christian?
I think it should be adopted like immediately. And in fact, it also begs the question is we have some documents like the host name document, which is lingering in this group. Maybe it should progress.
Sorry, could you speak louder because there's background?
We have a related document on the host name considered harmful. And maybe that one should go towards publication. I mean, we seem to be taking a long time there for no particular reasons. So to our specific question, I'd support having adoption now. It'd be a good idea.
Okay.
Christian, for the host name draft, we will send it to, we will request publication after the meeting.
Okay, thank you.
No problem.
Thanks. Okay. Thanks, everyone. So I guess we'll bring this to the list, but we do see, as before, support, and now it's Bob's turn. No. We don't have many things this time.
Hi there. When the slides come up, this is going to be a request for review of a document that's soon going to working group last call, probably on Friday in TSV working group. It's been around for quite a while. It's guidelines on adding congestion notification to protocols that encapsulate IP. So the basic idea is, next slide.
Oh, there's a point there. Oh, you don't have the point?
It's here.
Yeah.
Yeah, okay, the basic idea is that it's a best current practice draft. Given that ECN was added to IP in 2001, but that changed the lower interface, and nothing was ever really written about what protocols beneath IP should have to do. This is both the tunnels and lower layers. It's actually not straightforward. It's like most things about encapsulation are reasonably straightforward, but ECN has two problems. One, that the lower layers are often not in the IETF, so it's cross-organization. You know, it's IEEE, 3GPP, and there are some that are cross-area in the IETF, as listed there. And the other is that it's cross-layer, in that there's a need, as you'll see on the next slide, to send information both down the stack and up the stack. And also, some lower layers have very different feedback structures to others. There's more written in the draft, but there's two here called forward and up, or up and forward, depending on whether they've got their own way of marking ECN in their outer header. The big problem is incremental deployment, as the next slide shows. And this compares ECN with diffserv, or a traffic class identifier more generally, because it's sometimes called traffic class in, well, it's called that in V6, in fact. And with that, you're sending your requirements down the stack to the lower layer, or to the tunnel outer. Whereas with ECN, you're sending the fact that it's capable, the transport is capable of understanding ECN down the stack, and then the lower layer is sending possible congestion experienced up the stack. And you get a need to combine the inner and the outer at the egress of a tunnel or a layer egress, which is what RFC 6040 specifies in that table there. We're not changing that in the current work. We're just writing guidelines on how to write lower layer protocols and pointing them at various drafts and all the rest of it. So I'm just going to go through not what this draft says, but one of the major parts of it, which is very small and has just been split out into another little draft, which you'll see at the moment is individual, but the TSVWG chairs want to fast track it to PS. Because it's essentially it was a section of text in this BCP that updated a number of other proposed standards, and so we've taken that out as a proposed standard, so it all goes through the process smoothly. And the problem, it's a very simple little problem. RFC 6040 is about tunneling of ECN, and its scope was IP and IP tunnels, and it was unclear to people. Some people guessed that that meant also IP and IP where there's a shim in between, like, you know, GRE or GU that has just been talked about, and others guessed that it didn't mean that. So we thought we'd better make it clear. So this is just a minor update to say we do actually include that, and we've specified it as tightly coupled shim, in other words, where the shim is added at the same time as the outer, so that it is effectively something where the machine that's doing it can have in memory what was in the other header and what will be in the new one, so it can compare the two. And just in case, and in fact I'd like feedback from anyone that reviews this about this, we've said that RFC 6040 should apply because we figure we're talking about updating tunneling specs that have been around for many, hundreds of years. And so it may be infeasible to change implementations because of the way they've been structured. But if you think we could say must, we'd rather say must. And to give a feel for the specs, this is going, this has in the updates header. It's all that list there, 6040 itself, because it's widening the scope, and then the GRE spec. One I thought of since was NVGRE, but I don't know what the status of that is. Same problem, yeah. But I just sort of heard that GU may be going to overtake it or something. I don't know. I didn't know that, but.
David Black, NIP department. Both VXLAN and NVGRE have the same status. They were independent submission track docs.
Yeah. Yeah, it's just whether NVGRE is going anywhere. because I don't know.
Both are the same status, and as far as I know, neither VXLAN nor NVG are going anywhere. All the work that's going on in NV03 is new in caps.
Yep.
Even though one of them has a whole lot of name format in common, VXLAN is still new in cap.
Yep. Then carrying on down the list, there's all the L2TP, well, the version 2 and version 3. There's PPTP, and then added to the list are a number of protocols that are non-IETF ones, all the GTP ones from the 3GPP, GPRS tunneling. VXLAN, as just stated, which is informational in the IETF. So essentially, the idea of this is to specify implementations as being modified by to RFC 6040 support, and this RFC 60 BIS also lists a couple of good guys who have already done this. That's Gu and Genève. Thank you very much. Who already have specified this.
Eric Nordmark, you say standards track. It's not clear what status those things will have yet, but NVO3 is trying to figure that out.
I'm just going by what it says in the headers, but yeah, it says it says intended status. Yeah. Okay. Right. So next steps, we would really like someone to review both these. If you feel you may get forced to review them, you might want to pick the short one, which is 2 pages, before you get forced to read the other one, which is 29 pages. But obviously the one that's standards track is more important, but the other one is also much more generic. So someone with a bit of an architectural feel for all this would be useful. So yes, reviews please for both, and I've put up there the sort of things we're looking at for reviewability, you know, the comprehensibility gaps for the first one, but the second one, it's more is the list complete is the main thing because it's such a short one. And that point about can we make it a must for following 6040, or do we should it be a should? Would like that looked over, so I don't know whether there's any volunteers. How do you do volunteers in this working group?
Well, you can call for volunteers, but probably I'll encourage you to do it on the mailing list because we're starting to run out of time.
Right. Okay.
Okay, thanks. Thank you very much.
Thank you. I've got a dash because I've got another call now.
Okay. Thanks. Cheers. Yeah, thanks. It's Chris, right? So Chris is presenting on behalf of Ron. He's going to talk to us about EPING or EPING or...
Yeah, enhanced ping, it is. And seeing as we're running behind, I can probably do this in 5 minutes if I'm lucky. So as you might guess, enhanced ping is an enhanced form of ping or extended ping. And I'm not one of the authors, but they couldn't make it, so I'm giving this presentation for them. So the motivation is that when operators deploy a router, it might be useful to be able to use a numbered v4 interfaces or private address space for v4 or only a link local address on the v6 interface. But when you do that, you can't ping those interfaces from anywhere on the internet, and even in the case of like unnumbered IPv4 interfaces, even from within your own domain. So ePing comes to the rescue here. It's an application much like traditional ping. It sends a probe message, waits for reply. What's different about extended ping is that you have 2 interfaces that you're going to specify. One is the destination interface. That's the interface that the probe is going to be sent to, and that'll be an IP address just like in normal ping. And in addition, you specify a probed interface. That's the interface whose status is being queried. They're typically different from each other, but they could also be the same. And that kind of makes it normal ping. So that destination interface has to be a reachable IP address, just like in normal ping. And then the probed interface will specify with the interface name, index, or an address which may or may not be reachable. This is what a user would see executing the ping. In this case, they are specifying the destination interface is the last IP address there, and then they're specifying the probed interface with some option, and then they find out the status of the probed interface itself. Similarly here, they use a link local address. So in terms of what we need to do to ICMP to make this work, we create two new ICMP messages, the extended echo and the extended echo reply. The extended echo message is basically like a normal echo message, except it adds an IP extension header, or IP extension rather, ICMP extension that identifies the probed interface and carries the destination interface in the usual place. And the extended echo reply message, very similar to the normal echo reply, except it's got additional codes for telling you the status of the probed interface. And there's two versions posted. We're on version 1 at this point. Some comments have been received from the mailing list, in particular adding the ability to identify an interface by MAC address, various editorial comments, and we'll be posting a new version after IETF. And so eventually we'd like this to be considered for adoption at some point. Thanks.
Thanks a lot, Chris. So bear in mind, he's not the author, but I guess you're willing to take questions?
Yes.
Jelenkova, I have not read the draft, so but I have a question. So when you identify an interface, I assume, for example, for IPv6 link local, you should specify it with zone index, right?
Correct, correct. In fact, yes, I pointed out to the authors that link local addresses and MAC addresses, for that matter, on VLAN tagged interfaces might not be unique for a given router.
And the related question, so you said you can identify the interface by IP address or name. Is it O or N? So basically, if my interface has more than one IP address, can I specify interface and IP address? Both of them?
Right now, I think the semantics of that aren't really well defined in the draft, but we would welcome, I'm sure the authors would welcome that input.
Okay, thank you.
And I will help transfer that to them.
Thanks. One last question, Andrew, and then we move on.
Andrew Yurchenko. I see quite a bit of similarity within the SNMP GET for given OID. Right? Because we're sending a packet to an IP address and querying the status of the interfaces. So maybe some
True. Yes.
Christian Wittema. Chris, I think that you may want to develop a bit the security section there.
Excuse me?
I think that you already have a security section, which is reasonable, but it might need to be extended, because this idea that you can from afar probe things that were not otherwise visible obviously has some potential.
Yes, I agree. I will make sure the authors receive that information.
Thanks. Thank you very much. So again, the authors are not present, but we encourage people to send comments on the list. Thanks a lot, Chris. So next topic, Margaret's going to talk to us about bandwidth aggregation for network access, a new topic, and probably relevant for INTAREA and very ad hoc to us being next to the zoo, I guess.
So for several IETFs now, we've had an informal group meeting to discuss bandwidth aggregation for network access, or what we call banana. The banana scenario is a very strict subset of a site multi-homing scenario. It's a scenario where you have multiple links to a home or small office, and they are provided by the same service provider, which opens up a possibility for this sort of picture, where you've got a host A in a home or small office, you've got a host B somewhere out on the internet, And the CPE is used, is connected to two different types of link. In this case, in this particular example, an LTE link and a DSL link, but it's not specific to that. And you could have a concentrator in the operator's network that also can combine those two links. And in this case, there are various options for how to do things like load sharing across those two links for bandwidth aggregation, and or failover. If one of those links is down, the traffic could use the other link. There are a lot of people who are doing work in this area throughout the internet. The Broadband Forum is working on some architecture for this, but there are many operators who are out there already implementing this in several different countries, hundreds of thousands of users of proprietary solutions in this area. And we've been getting a lot of those people together. When we first got together, there were 7 different proposals for doing this, where we don't have 7 left. And I'll talk to you about a little bit about what happened. And we're talking about, how to solve this problem using IETF protocols. There were, at one time, as I said, 7 different proposals. At this point, what's left as internet drafts that haven't expired are 2 MPTCP-based proposals that are going to be merged into one after this meeting. I think the agreement was very close to this meeting, but when they presented them in MPTCP, they had already agreed to merge them. And a GRE tunnel-based proposal, which is a proprietary proposal right now, going on the independent stream, that's already been deployed to multiple hundreds of thousands of homes, but which could provide the basis of a standards-based proposal. There were other proposals as well. There was a mobile IP-based proposal that was quite interesting, and there was quite a bit of interest in it, but the specs seem to have expired. I need to get with the authors and find out if they're going to be updated. And there was also a list-based proposal that was experimental, and the authors were doing mostly interested in doing simulation and measurements and stuff on their simulation. And there were some others, some other proprietary choices out there that haven't been documented in internet drafts. We also have a couple of other drafts out there I want you to be aware of. One of them is the problem statement document that tries to describe that scenario in a bit more detail. And my document, Considerations for Bandwidth Aggregation, that tries to talk about sort of operational and architectural and other considerations that one would want to keep in mind if one were choosing a solution for this. And one of the things we're trying to figure out right now is where to put this work in the IETF, or how much of it to take into the IETF. But my considerations document right now brings up issues like per flow versus per packet multiplexing, right? You can say, well, per flow is always better. It's the first answer you get from everybody. Oh, you got to do per flow load sharing, except that from a home, there might at any given time be only 1 or 2 or 3 flows, and doing per flow load sharing actually gets pretty poor results. So people are doing per packet, or like in the case of MPTCP, they're not absolutely doing per flow. They are actually able to share the load of one flow across multiple connections. I talk about whether UDP gets load balanced or bypassed. In the MPTCP case, it's easy to do TCP. UDP has to go a different route. Some people are just using MPTCP and bypassing UDP. That might be okay if the amount of UDP traffic stays low, but if QUIC continues to run on UDP and becomes popular, maybe that won't be okay. I talk about those things in the draft. End-to-end TCP connections versus middle boxes actually terminating the TCP connections. Yeah, I think I have like 3 slides left. MTU and fragmentation handling, IP address range, etc. So different solutions have different trade-offs. I think there's pretty strong agreement in the group that's been meeting, which has no standing in the IETF, that there might be room in the world for more than one solution. The considerations document is just trying to explain the trade-offs. Tonight there's going to be a bar-off at 8 o'clock in Schoenberg. So if you're interested in this topic, please come. One of the things we want to talk about there is next steps and what common work we could do, or what work we could do here in the IETF, and then decide whether we can bring the work to the interior working group possibly, or to another group. And that's basically why I'm here today, is to talk to people about the work here that doesn't have an IETF home, the problem statement considerations, the GRE tunnel, a potential GRE tunnel-based solution, a standard one, possibly based on current proprietary work, and even the MPTCP-based solution does not have a home. They talked about rechartering to do it, but there was quite a bit of objection to that in the MPTCP group, saying it was really more of an int-area problem. So should we be doing this kind of work? And if so, where and how? Here in int-area? Somewhere else? Does anybody have any opinions about that?
Okay. Okay, thank
or
you.
questions in general?
If you have a 30-second time to provide feedback, otherwise we encourage you to assist tonight to this bar-off.
I also attempted to, I think we did send information to the list about the bar-off. So if anyone needs any more information about the bar-off, you can find me at the end.
Thank you very much. So we have one slider from Charlie that we're out of time, but if Charlie's here and willing to present, maybe he can just provide this, and if people want to hear. Charlie? Okay.
So we're out of time, so I can't present, is that right?
Yes, I mean, it's
okay.
One slide, pretty much info, right?
Okay, hold on. Well, this will be very short. Hold on, but I'm not very short. So next slide, please.
Yes.
So this is the draft about more or less below layer 3 characteristics of wireless links. And we've had the draft out there. It's sort of, it's gotten some comments and finally, as earlier this week, I responded to all the comments that were on the list and put out a new version of the draft, which I pretty much don't reckon too many people had time to read, but please, if you are interested, take a look. It's quite short. So we included more citations for the kinds of protocols that could be affected by this. For instance, ad hoc routing protocols. Alex asked a question about whether we intended to be talking about layer 2 hops or layer 3 hops. Well, really, we're talking about what kind of effects there are on links between neighboring devices, but really it's in sort of in the context of layer 3 hops. There was a suggestion to reduce the sort of informal nature of some of the discussion, so that was done. The figures were redrawn, better captions, and then some wordsmithing. So all in all, I think that it was relatively incremental, except maybe the next slide, please. There was a suggestion for making in this draft a discussion about how to determine the quality of a link. And link quality indicators is a not trivial subject. It's, you know, just, I guess you would say it's related to metrics over a link. And there's all kinds of things you can measure, and whether it's bidirectional or useful, or what thresholds there are, and so on. And so I think that it does deserve discussion, but I don't think it belongs in this draft, and it would be a whole new area for discussion. So I think that's my last slide.
Yep. Thank you very much, Charlie. So any quick feedback on this last couple of slides to Charlie? Otherwise, probably we should take this to the list. I think it's good questions, but maybe better to discuss it on the list.
Okay.
Okay.
Thank you very much.
So apologies for the other presenters. We're out of time, but I mean the slides have been uploaded. Feel free to ask for feedback on the list. And thank you very much for attending.